Hi students, good morning all of you. Hope you are all doing good. Welcome to 44th lecture in this course. At present we are discussing definite integrals unit and our today's topic is area under the curves. In this lecture I will be discussing some more problems on area under the curves using definite integrals. Here is the first problem in this lecture. Find the area enclosed by the curves y square is equal to 4x comma y square is equal to 4 into 4 minus x. So these two equations represents parabola. We have discussed how to plot these two curves in the lecture of graphical transformations. Okay, so plotting these two equations will give me this graph. Okay, and as represented, the blue color curve is the y square is equal to 4x curve, and that of the red color curve is y square is equal to 4 into 4 minus x. Okay, now we need to identify the region area or the region enclosed by these two curves. So clearly this is the region that is enclosed by these two curves. Let me shade this region. So this is the region that we have been asked to find out. Okay, now let me show you the shaded part. So the required region is shaded in two colors here. One is in yellow color. This is the yellow color, and the other one is the orange color region. Okay, now I have shaded the entire region into two parts purposefully because this yellow color region is under the blue color curve, namely y square is equal to 4x, and that of orange color region is under the curve y square is equal to 4 into 4 minus x. So the entire region is not under the same curve. That's why I have divided this entire area into two parts, namely A1 and A2, let us say. Okay, now we need to find out this point of intersection. Okay, for that let me solve this equation to find out the point of intersection, solving these two to find point of intersection. Yes, y square is equal to 4x and y square is equal to 4 into 4 minus x. So solving these two equations gives me 2x is equal to 4 implies x is equal to 2. Right, so this is the straight line, namely x is equal to 2. This is x is equal to 2 straight line. So if we want to find out the y coordinate, substitute in this curve. So y square is equal to 4 into 2, that is 8. So y is equal to plus or minus 2 root 2. Yeah, so this point will be 2 comma 2 root 2, and this point would be 2 comma minus 2 root 2. Yes, okay, now the entire okay, and further the yellow color region is divided into two parts, namely A11 and A12, and that of orange color region is divided into A21 and A22. Why this entire A1 is divided into two parts? Because this portion of the area is under the curve y is equal to root 4x, and whereas this is under y is equal to minus root 4x, and whereas this portion of the area is under the curve y is equal to root of 4 into 4 minus x, whereas this portion of the curve is y is equal to minus root of 4 into 4 minus x. Okay, now let us find out the required area. Let me write down whatever is being discussed here. Here is the solution. The required area A is divided into two parts, namely A1 and A2, and further A1 is divided into two parts, namely A11 and A12, and A2 is divided into two parts, namely A21 and A22. Now let us find out A1. So for that we have to find out A11 first. So what is A11? A11 is equal to, it is integral, this point is 0 comma 0 and this point is 4 comma 0. Now so this is from 0 to 2 under root 4x into dx. So under root 4 is 2 into integral 0 to 2 root x, that is x to the power 1 by 2 dx. So upon integrating that, I will be getting x to the power 3 by 2 divided by 3 by 2. So the limits are, integration limits are 0 and 2. So that is equal to 4 by 3 into, if I substitute the upper limit, I will be getting 2 to the power 3 by 2 minus 0 to the power 3 by 2. So that is equal to 4 by 3 into 2 root 2. So that is equal to 8 by 3 into root 2. Now let us find out A12 as well. So A12, this portion of the curve is under minus root 2 root of 4x. So the integral for finding that area is 0 to 2. Since it is below the x-axis, so we have to add one minus here, minus root of 4x dx. So that is equal to 0 to 2, 2 into root x dx. And anyway, just now we have found out that this is equal to 8 by 3 into root 2. So this implies A1 is equal to A11 plus A12. So A11 plus A12 both are equal. So this is equal to 2 into 8 by 3 root 2. So that is 16 by 3 into root 2. Right. So this area A1 is 16 by 3 into root 2. Now let us find out area A2. And before finding A2, I would like to share one point here. We have observed that A11 is equal to A12. Geometrically, that means this is A11 is equal to A12, A11 is equal to A12, because we know that this curve is symmetric about x-axis. So this is clearly the upper part is clearly the reflection of the lower part. So the area covered by the upper part is same as the area covered by the lower part with the x-axis. So because of the symmetric nature, okay, we have got A11 is equal to A12. Now let us find out area A2. So A2, for finding A2 we require A21. Let us find out A21. A21 is integral 2 to 4 this portion, this part of the curve we need to, what is the equation of this part? So just now we have discussed it. It is under root 4 into 4 minus x into dx. So that is equal to 2 into integral 2 to 4 root of 4 minus x, that is 4 minus x whole to the power 1 by 2 dx. So that is equal to 2 into, what is integration of 4 minus x whole to the power 1 by 2? It is 4 minus x whole to the power 3 by 2 by 3 by 2 into 1 by minus 1, 2 to 4. So that is equal to minus 4 by 3 into 4 minus x whole to the power 3 by 2, 2 to 4. So that is equal to minus 4 by 3 into, if I substitute the upper limit, I will be getting 4 minus 4 whole to the power 3 by 2 minus, I substitute the lower limit, 4 minus 2 whole to the power 3 by 2. So that is equal to minus 4 by 3 into, so 0 minus 2 to the power 3 by 2. So that is equal to, so minus 4 by 3 into, this is 2 root 2. So this is 8 root 2 divided by 3. So area A21 is equal to 8 root 2 by 3. And similarly, let us find out A21. A21 is equal to integral 2 to 4. Now this curve is below the x-axis, so we have to add minus here. So minus of minus root of 4 into 4 minus x into dx. So that is equal to integral 2 to 4 root of 4 into 4 minus x dx. So that is equal to, just now we have found out that this is 8 by 3 into root 2. And here also we have seen A21 is equal to A22, just because of the symmetry. The curve is, that curve is also symmetric about x-axis. Okay, now this implies A2 is equal to A21 plus A22, that is equal to 2 times 8 by 3 into root 2, that is 16 by 3 into root 2. So the total area A is equal to A1 plus A2, that is equal to 16 by 3 into root 2 plus 16 by 3 into root 2. So that is equal to 32 by 3 into root 2. So area A is equal to 32 by 3 into root 2 square units. Hope you have understood this problem. Here is our next problem. Find the area enclosed by the curves y square is equal to 12 into x plus 3, comma y square is equal to 20 into 5 minus x. You can identify these two curves are parabolas, which were discussed in the graphical transformation. So plotting these two parabolas on the coordinate axis will give me this picture. Okay, and here you can see that the blue color curve is y square is equal to 12 into x plus 3 curve, that is the y square is equal to 12 into x plus 3 parabola, and the red color curve here is y square is equal to 20 into 5 minus x. Okay, now we have to identify the area of the region enclosed by these two curves. So this is the area of the region, this is the required region that we need to find out. Okay, and let me share this. So this shaded region is the required region that we need to find out, and you can see that the entire region is split into two parts. One is yellow, one is shaded in yellow color, and the other one is shaded in the orange color. This is divided into two parts because the entire area is not under the same curve. See, from this point to this point, it is under this curve, that is the blue color curve, whereas from this point to this point it is under the other red color curve. Okay, let us find out this point of intersection. Okay, the point of intersection, let us find out. How do we find out the point of intersection? The point of intersection by solving these two equations. So solving these two equations, I get 12 into x plus 3 is equal to 20 into 5 minus x. So that becomes 12x plus 36 is equal to 100 minus 20x. So that becomes 32x is equal to 64, implies x is equal to 2, and you can see that even in the graph also this is represented by the straight line. Okay, x is equal to 2. This line is x is equal to 2 straight line. Now if I substitute the point 2, x is equal to 2, I will be getting the y values. So if I substitute 2 in this equation, I get 12 into 2 plus 3, that is 60. So y square is equal to 60. So y square is equal to 60 implies y is equal to plus or minus root 60. So the point here is 2 comma root 60, and here this is 2 comma minus root 60. Okay, now we have got this point also. Let me write that here also, 2 comma root 60 and 2 comma minus root 60. Right, and further this area, this is divided as a1 and a2. The entire area is again divided into two parts, namely a1 and a2. Further this a1 is divided into two parts, namely a11 and a12, and this a2 is further divided into a21 and a22, because this a11 region is under this portion of the curve and a12 is under this portion of the curve. So what is this portion of the curve? This is y is equal to under root 12 into x plus 3, and this is y is equal to minus root of 12 into x plus 3. Now this is this upper part of the curve is y is equal to under root 20 into 5 minus x, and this is y is equal to minus root of 20 into 5 minus x. I hope you have understood this. Let us find out the areas, individual areas. So let me write the solution. Let us find out the solution here. Here is the solution. Okay, the entire area A is divided into two parts, namely a1 plus a2, and further a1 is divided into a11 plus a12, and this a2 is divided into two parts, namely a21 plus a22. Right, now let us find out the area a1. So area a11, so area a11 is equal to, this is integral, here this point is from the parabola, this is equal to minus 3 comma 0, and this is 5 comma 0. So it is, the integral is from minus 3 to 2 into, this integrand here is under root 12 into x plus 3 dx. So taking out that root 12 outside of the integral, then this becomes minus 3 to 2 integration x plus 3 whole to the power 1 by 2 dx. So that is equal to root 12 into, so the integration of x plus 3 whole to the power 1 by 2 is x plus 3 whole to the power 3 by 2 divided by 3 by 2, and I have to write the limits here, minus 3 and 2 here. So this becomes root 12 can be written as 2 root 3, and this denominator 3 by 2 can be written as 2 by 3 into this x plus 3 whole to the power 3 by 2 evaluated in the limits minus 2 comma 3. Let me write this is 2. So this is equal to 4 by 3 into root 3 into, now let me substitute the upper limits in that integral. So this is 2 plus 3 whole to the power 3 by 2 minus 3 plus 3 whole to the power 3 by 2. So that is equal to 4 by 3 root 3 into, so this is 5 to the power 3 by 2 minus 0. So that is equal to, this can be written, this is further simplified as 4 by root 3 into, this is 5 into root 5. So that is equal to 20 into root 5 by 3. So a11 value is equal to 20 into root of 5 by 3. Now let us find out a12. a12 is integral, again the limits are same, minus 3 to 2, but this curve is below x-axis, that means negative. In this case, how do we find out this? So it is minus of minus under root 12 into x plus 3. You just we are applying the result 2 here. So that is equal to integral minus 3 to 2 root of 12 into x plus 3. So just now we have found out the value of this integral. This is equal to 20 into root 5 by 3. So this implies a1 is equal to a11 plus a12, that is equal to 2 into a11, that is equal to 40 into root 5 by 3. Let me box this expression. Yeah, now you can let us try to understand this geometrically. You can see this portion of the curve. We know that this curve is symmetric about x-axis. Because of the symmetry, the area a11 is equal to the area a12. Okay, because of that symmetric nature. All right, let us find out area a2. So to find out area A2, I need to find out A21 first. Area A21 is equal to, now the limits are from 2 to 5. So it is from 2 to 5. What is the function there? Y is equal to under root 20 into 5 minus x. So this is under root 20 into 5 minus x into dx. So if I take out that root 20 out of the integral, then this becomes 2 to 5, it is 5 minus x whole to the power 1 by 2 dx. So that is equal to root 20 into 5 minus x whole to the power 1 by 2 integration is 5 minus x whole to the power 3 by 2 divided by 3 by 2 into 1 by minus 1. I have to write down limits. This is 2 and 3. Okay. Now this value is equal to, so here this can be written as 2 by 3 into root 20 minus this minus, I am taking it outside. So this is 5 minus x whole to the power 3 by 2. This must be 5. Yeah, this must be 5, 2 to 5, right? So this is equal to minus 2 by 3 into this root 20 can be written as 2 into root 5, right? Okay, so if I substitute the upper limit, then this becomes 5 minus 5 whole to the power 3 by 2 minus 5 minus 2 whole to the power 3 by 2. So that is going to be minus 4 by 3 root 5 into, this is anyway 0, minus 3 to the power 3 by 2. So that is equal to minus 4 by 3 into root 5 into minus, this is minus into minus plus, so this is minus into minus plus, this becomes 3 root 3. So that is equal to 12 by 3 root 5 into root 3. So that is equal to 12 into root 5 by 3. Yeah, so that can be written as 12 into root 5 by 3 square units. So this is my A2 value, A21 value. Now what is A22 value? A22 value is equal to, now we have to find out this portion of the curve. So that is equal to 2 to 3, so 2 to 5. This becomes minus of minus root of 20 into 5 minus x dx. So that is equal to integral 2 to 5 root of 20 into 5 minus x dx. So just now we have evaluated this. This is equal to 12 into root of 5 by 3. So this implies A22 is equal to A21 plus A22. So that value is equal to 2 into 12 into root 5 by 3. That is equal to 24. So this implies area A is equal to A1 plus A2 anyway. So what is A1? A1 is equal to, this is given here, 40 by 3 into root of 5 by 3 square units plus this is 20 by 3 into root of 5 by 3 square units. So sorry, I think this is 24. This is 24. So this is equal to 64 by 3 into root 5 by 3 square units. So we have got the area of the required region, that is equal to 64 by 3 root of 5 by 3 square units. Hope you have understood this problem. Let us solve the next problem. Here is our next problem. Find the area enclosed by the curves. Actually there is a mistake here. This this has to be y is equal to sine pi x, y is equal to x square minus x, and x is equal to 2 curves. So there 3 curves are given. One is a straight line, namely x is equal to 2, and y, and the other one is a parabola, y is equal to x square minus x, and the first curve is y is equal to sine pi x. Okay, so all these curves are familiar to us. Plotting all these curves on the coordinate axis will give me this figure. So the blue colored one is sine pi x, and you can see that how they have got this sine pi x. If I substitute 0, then this becomes 0. If I substitute 1, then sine pi is equal to 0. So this is 0, 1 comma 0. And if I substitute 1 by 2, so this is 1 by 2, it is at its peak. Okay, sine pi by 2 value will be getting. So hope you understood this sine curve. And the y is equal to x square minus x is a parabola, which is in the red color. Okay, now we have to draw one more line that is missed out. So x is equal to 2 straight line. X is equal to 2 straight line is a vertical straight line. This is my x is equal to 2 straight line. Now we have to find out the area enclosed by all the 3 curves. Suppose your guess is this one. This is only covered by the sine curve and the parabola and the x-axis, of course, but x is equal to 2 line is missing, so obviously your guess goes wrong here. And if you look at this portion, it is covered by the parabola on one side, x is equal to 2 on another side, and the sine curve on one side. So this is the required region that we need to find out. So after identifying this, of course these are the point of intersection that anyway known to us, sine pi x and y square is equal, y is equal to x square minus x at intersect at 1 comma 0. Okay, and afterwards these two curves will not intersect. Okay, now let me show you the required region in the shaded portion. So the required region is shaded in yellow color. So let us find out the area of the shaded region. Of course here anyway this can be split into 2 parts, namely a1 and a2, and a1 is under the curve the parabola, and a2 is under the curve sine pi x, and this is the straight line x is equal to 2. Okay, let us find out the area solution here. Area A is splitted into 2 parts, namely a1 plus a2. So the first area is under the parabola, which is above the x-axis. So integral you can write it directly. So this is 1 to 2, that is x square minus x, x square minus x into dx. Directly we'll be getting that. But the second area a2, how do we get? The limits are one and the same, but this curve is below the x-axis in this region. So in these cases, how do we find out it? How do we find out the area? This is minus sine pi x. This is minus sine pi x into dx. So this is equal to integral 1 to 2 x square minus x minus sine pi x dx. Of course we can apply result 3 also, but anyway I have used fundamental rules to evaluate the area. Now let me do the integration. So integration x square is x cube by 3 minus x square by 2 minus integration sine pi x is minus cos pi x divided by pi. So evaluated in the limits 1 to 2. So this is equal to x cube by 3. Let me rearrange the terms here. X square by 2 plus cos pi x by pi. The lower limit and upper limits are 1 and 2 respectively. So let me substitute the limits. So the first one is 1 by 3 into 2 cube minus 1 cube minus 1 by 2 into 2 square minus 1 square plus 1 by pi into, this is cos 2 pi minus cos pi. Right, now this value is equal to 2 cube minus 1 is 7. This is 7 by 3 minus 2 square is 4 minus 1 3 by 2. This is 3 by 2 plus 1 by pi into cos 2 pi value is 1 and that of cos pi value is minus 1. So this becomes 2 by pi. Now let me simplify this fraction, that is equal to 6. So this is 14 minus 9 plus 2 by pi. So that is equal to 14 minus 9 is 5 by 6 plus 2 by pi. So the required area is equal to 5 by 6 plus 2 by pi square units. Hope you have understood this result. Okay, let us solve the next problem. Here is our next problem. Prove that the curves y square is equal to 4x, x square is equal to 4y divide the area of the square bounded by the lines x is equal to 0, x is equal to 4, y is equal to 4 and y is equal to 0 into 3 equal parts. Okay, here the two parabolas are given and a square is formed out of the 4 lines given here. X is equal to 0, x is equal to 4, y is equal to 4 and y is equal to 0. X is equal to 0 and y is equal to 0 are the coordinate axis, that is one is x axis and other one is y axis. X is equal to 4 is a vertical straight line and y is equal to 4 is a horizontal straight line in the positive quadrant. Okay, this is a this forms a square. These 4 lines form a square in the first quadrant. Okay, what is it they are asking is these two curves divide the square into 3 equal parts. If I plot all these curves on the coordinate axis, we will be getting this figure. So this is the square that they are talking about. This is y is equal to 4 line, this is x is equal to 4 line, this is x axis and the y axis. This is the square that they are talking about. Okay, now these two curves divide this square into 3 equal parts. This is what they are asking. That means area wise we have to show that area wise these 3 regions are equal. There are 3 parts, namely area 1, this is area 2 and this is area 3. Now they are asking us to show that this square is divided into these 3 regions of equal size. Okay, equal means in terms of area we can show that they are equal. Okay, now this red color curve is y square is equal to 4x curve and this blue color curve is x square is equal to 4y, and this red color portion, the upper part is given by y is equal to root 4x. That you have to remember. Okay, now let us see how do we go about finding areas. Anyway, all these curves intersect at some point and you can see that this horizontal straight line and vertical straight line intersect at 4, 4. I think this point is 4, 4. Okay, let me show you the shaded region. Sorry, yeah, this is the shaded region. So This is area A1, let us say. This is area A2 and this is area A3. Okay, now we have to find out areas one by one, and this is 4 comma 4. The point of intersection is 4 comma 4. Anyway, you can check that in the parabola. If I substitute 4 comma 4, both the parabolas satisfy that. Anyway, now the point of intersection is known to us. Now we will find out each area. So let us start with the area A1. So solution here, let us find out area A1. So area A1 is bounded by this y-axis on one side, and this is the horizontal straight line, and this is the red color curve. So what is this red color curve? Is given by y is equal to root 4x, and this equation is what? This horizontal line equation is y is equal to 4. So this is integral 0 to 4. This is integral 0 to 4. The upper curve here is y is equal to 4 straight line minus the red color curve is root of 4x into dx. So that is equal to integration 4 is 4x minus this is 2 into x to the power 3 by 2 divided by 3 by 2. So we have to evaluate this in the limit 0 to 4. So this is 4 into 4 minus 0 minus this is 4 by 3 into 4 to the power 3 by 2 minus 0 to the power 3 by 2. So this value is equal to, this is 16 minus 4 by 3 into 4 to the power 3 by 2 is root 4 is 2, 2 cube is 8. So this is equal to 16 minus 32 by 3. So that is equal to 32. So 16 3s, 16 3 is 48. So this is 16 by 3 square units. 16 by 3 square units. Now let us find out A2. So how do we find out these two? A2 is bounded by the red color curve and the blue color curve on the downside, these two curves. Okay, now let me evaluate that integral. Let us find out that. So again the limits are from 0 to 4 only. This time this upper curve is root 4x minus the lower curve is y is equal to x square by 4. So this is x square by 4 dx. So upon integrating, so root 4x, so this can be written as 2 into root x integration is x to the power 3 by 2 by 3 by 2 minus 1 by 4 into x cube by 3 in the limits 0 to 4. So this is equal to, this is 4 by 3 into 4 to the power 3 by 2 minus 0 to the power 3 by 2 minus 1 by 12 into 4 cube minus 0 cube. So this is equal to 4 by 3 into this is 8 minus 1 by 12 into this is 64. Yes. So that is equal to, this is 32 by 3 minus, so 3 times and this is 6 times, 16 times, 16 by 3. Here 32 by 3 minus 16 by 3. So this is equal to 16 by 3 square units. So area A2 is equal to, now we can find out area A3. A3 is equal to area of the square minus area A1 plus area A2. So what is the area of the square? It is 14 into 14 minus area A1 is 16 by 3 minus 16 by 3. So this is 16 minus 32 by 3, which is again 16 by 3. So this implies A1 is equal to A2 is equal to A3. So this proves the result. Now A3 you can find out, this is an exercise for you. A3 you can find out using find A3 using integral. Okay, using integration, let us say using integration. So set up an integral for that to find out area of the region A3. Okay, now let us solve the next problem here. Here is our next problem. Show that the area of the region bounded by the ellipse x square by a square plus y square by b square is equal to 1 is pi ab. Also deduce that area of the circle x square plus y square is equal to a square. Now this is one of the striking result I can say. So far we know the area of the some regular polygons. One is circle and triangle, all these things. For the first time this is not known to us earlier. So we will be finding the area of the ellipse as an application of the definite integrals here. Okay, now let us find out the area of this area of the ellipse. Anyway, I have explained you in the first lecture on elementary graphs regarding the ellipse x square by a square plus y square by b square. Here I am considering this ellipse, sorry, yeah, 1 minute. Let me 1 minute. I'm not getting my pen. Yes. So this here I am considering that ellipse where a is greater than b, that is the major axis is on x-axis and the minor axis is on the y-axis. So this is going to be minus a, and this is going to be, sorry, this is going to be a, and this is going to be this is going to be b, and this is going to be minus b. And we have discussed during the first lecture the ellipse is symmetric about x-axis. So it is symmetric about x-axis, symmetric about x-axis, symmetric about y-axis, symmetric about origin. All symmetries are available in the ellipse. So because of the symmetry, what I can do is I can divide the entire region into two parts, namely A1 and A2. Let me show you the shaded region here. So the entire region is divided into two parts based on the symmetric property of the ellipse. So here area A1 is equal to area A2, and further because of the symmetry A1 is divided into, let us say, A11 plus A12. So let me write this here. This is A1. Let me write it as A11 and A12. Let me write this here. This is A2. This is A21 and A22. Okay. We have concluded that a1 is equal to a2 because of the symmetric property of the ellipse. Fine. Now further, since it is this portion is symmetric about y-axis, this is, so I can further say a11 also is equal to a12 further, because of the symmetric nature of this is because symmetric nature of x-axis, symmetry about x-axis. This is because symmetry about x-axis. This is because symmetry about y-axis. Yeah. Now, so it is enough if I find out only this portion or this portion. Once I find out this portion, it is 4 times this area. So let me write down all these things here. Solution. So the entire area ellipse is divided into two parts, namely a1 plus a2. This is just because of the symmetric nature of the curve is symmetric about x-axis. So one is shaded in yellow color region and other one is shaded in the green color portion. And further, a1 is equal to a2. a1 is equal to a2, so this is equal to 2 into a1, let us say, right. Now further, this a11 is equal to a11 plus a12, and this and a11 is equal to a12. This is just because by symmetric property, symmetric about y-axis, symmetric about y-axis. So this implies a1 is equal to 2 into a11 or 2 into a12, right. So area A is equal to 2 into a1, that is equal to 2 into a12, that is equal to 4 into a12. That means if you find out a quarter portion of the parabola, ellipse, then we can find out the area of the complete ellipse. Okay, let us find out the area of the region A12. Okay, so how do I go about this? So let us set up the limits. So this is anyway 0 and this is a here, this is a and this is b, and this portion is given by y is equal to b by a into under root a square minus x square. Okay, so how do I get that? So I have this equation x square by a square plus y square by b square is equal to 1. So y square by b square is equal to 1 minus x square by a square, and from this I get plus or minus b by a into under root a square minus x square, and the positive r y is equal to root b by a into root of a square by x square is given by the upper part of the ellipse, and minus b by a into root of a square minus x square is given by the lower part. Okay, so a12 is equal to integral 0 to a b by a into under root a square minus x square. Since the curve is above x-axis, directly if I integrate it, I will be getting that area, right. So that is equal to b by a into, so what is the integration of under root a square minus x square? So it is x by 2 into under root a square minus a square minus x square plus a by 2 into sine inverse x by a in the limits 0 to a. So I think this is a square by 2, right? So this is b by a into, if I start substituting the limits, so this is a by 2 into a square minus 0, a square minus a square minus 0 by 2 into a square minus 0 square. So from this we will be getting nothing. So it is a square by 2 into, if I substitute the upper limit, it is sine inverse a by a minus sine inverse 0. So this is equal to b by a into, so from these two terms we will be getting 0 plus a square by 2 into sine inverse a by a, sine inverse 1. So sine inverse 1 is pi by 2. So this is b by a into a square by 2 into, this is pi by 2. So 1 a gets cancelled here, then I'll be getting pi ab by 4. So area A12 is equal to pi ab by 4. This implies area of the ellipse A is equal to 4 times A12. So 4 times A12 is equal to 4 times pi by 4 into AB, that is equal to pi into AB, right? Now from this we can deduce the area of the circle as well. So how do we get the circle from the ellipse? If A is equal to B, then the ellipse becomes the circle. Ellipse becomes the circle. So if I substitute A is equal to B, put A is equal to B in the above formula, we get area of the circle is equal to pi into A, that is equal to pi a square. See, circle is a particular form of an ellipse. Actually, ellipse is more generalized form when the major axis length is equal to the minor axis length, or major axis length, this is called the major axis length. Okay, this is minus a to a, and this is called the minor axis. Okay, so when these two are equal, then that becomes circle. Okay, anyway, if A is equal to B, what I can, the ellipse becomes circle. So ellipse becomes circle. This is particular type of the ellipse. So for this ellipse, what is the area? It is pi a square, and we know x square plus y square, x square plus y square is equal to a square, is a circle with the radius a units, right? So with the radius a units. So what is the area of the circle with radius a units? So area is equal to pi a square, pi r square. So area is equal to pi a square. So we have got the area of the circle as pi a square. So it is consistent with the existing result. Hope you have understood this derivation.